All right. So just as a starting point, if you've never worked with Android before, um, just do developer.google.com. Should take you to the site where you have the Android crap. It's a Java-based technology. So once you're here, click on Android.
We found a thing today called, X number of reasons of why you shouldn't use Firebase.
Oh, really?
Yeah.
Was it
I forget.
good or bad?
I don't remember. Because it was at work and I heard people talking about it and they didn't post the link.
All right, so in any case, there's a thing that says Get Android Studio. So click on that. It'll figure out what kind of computer you're currently on, blah, blah, blah. I already have it on this machine. So download that. If you've ever used Eclipse, Android Studio is a superset of Eclipse. So it used to, the Android IDE used to be a plugin for Eclipse. Now it's their own product, but this will give you your tool set. This will work on a Mac or a PC or on Linux. So whatever platform you have, you'll be able to do it on there. So let's go ahead and open up Android Studio here. All right, so what we really want to start off with is thinking about how do we mimic registers. All right, so we may actually not write tons of code today, but we want to start thinking about if we were writing an emulator. Let me close this one. Start a new Android project. Actually, that's interesting. So this is 2.1.3. And it looks like that, didn't they say it was like 2.2 something over here?
Yeah, I got 2.2 with a fresh download.
That's weird.
It's an update. Try to update it.
Where's the...
Bigger.
Otherwise, it's under help.
Check for update.
Oh, there we go. Remember when I said they update like weekly? I was just on here yesterday, and this update was not. They update it often. Yeah.
Did you see CRS out today?
Yeah, I didn't see that it actually had dropped, but I knew it was supposed to come out today.
Is it good?
I haven't used it. Well, I mean,
All I know
Besides
so
the name isn't terrible.
I just put it on my work computer while sitting here.
Instead of
the only
mountain
thing that
lion,
was,
it's a mountain range.
Well,
Alright.
instead of El
at least it's not freaking El Capitan.
all right. So while that's cooking, let's think about how do we implement registers. So we saw by our documentation here. Let's go back here. Let's get to our picture that listed all the registers. Okay, so these guys. So we have kind of 4 special registers, these general purpose ones that also have a high and a low. Okay, so these are kind of our first target. So let's kind of forget about the rest of these for a few minutes. Well, maybe even a few classes, and let's just think about these. So when we think about registers, what kinds of values? When I say a register is 16 bits, what kinds of values live in that register? Bits. So you can think of it as integers, you can think of it as bytes, you can think of it as shorts, whatever. But at the end of the day, 16 zeros or ones is what actually lives in the register. So we would probably implement registers as arrays, right? So AX would be a 16. Oh, let's actually, why don't we just write it? So this would be an integer array, size 16, something like that. BX, integer array, size 16. CX, DX. All right. Now, within these, we also have subregisters. We have AH and AL. These guys. Now, each of these guys are 8-bit registers, so we might be inclined to treat these as their own 8-bit things. But the reality is that AH and AL are actually the first 8 and the last 8 bits of this integer array. So what we probably should do is implement AH as an 8-bit register. And AL as an 8-bit register. And then refer to AX as those two glued together. So whenever we refer to AX, what we're doing is we're looking at the concatenation of AH and AL. Does that make sense?
Did you almost just stack those arrays?
Well, I mean, we could think about how we want to organize them, I guess, later. But for right now, we want to think about that these 8 bits and these 8 bits represent the same 8 and 8 bits for AX. We can't have them existing twice. So we're going to be better off having the separate registers implemented as 8 bits, and then have this guy, whatever we refer to AX, think of it as AH and AL concatenated for the bits. Let's see where we're at over this guy. Picked a bad time to update there, Curcio. Way to go.
I finished already though.
Oh, well, good for you. You want a cookie?
I would love a cookie right now.
Really? Fortunately, all I have is a legendary 895 belt.
I'm gonna start doing the Aaron Rodgers like self check too. You know?
Discount double check. What was the score, Rodgers? It's 895.
It'll be 905 next batch.
Oh, they're upping the eye level?
You can upgrade it somehow.
Oh.
Keep it relevant.
Well, I'm sure I won't need to upgrade. I'll probably just get more.
With your luck, you know.
See, I think what's more entertaining lately is like all the Peyton Manning commercials. That's like what he's doing.
Yeah.
Now that he's not playing. Peyton on Sunday morning.
Right, yeah, I've seen it. Lionel Richie. You know who that is, right?
Yeah.
Lionel Richie. Is that before your time, or?
It's before my time, but
He's still alive, so not.
Well, there's a lot of people who are still alive that nobody has an appreciation. So think about like NFL. Every year, people who are NFL fans, how often do they hear about person X, Y, and Z that was some stud back in the 50s or something?
I mean, if they were good.
I don't think you hear about them until they die.
Yeah, I think that's mostly true. Or like
in a ditch somewhere. You don't hear it until they die.
it's like they were really good, then they went into retirement and just basically faded out.
like what's the guy's name? Johnny Unitas? Is that it? What do we know about him?
Did he get arrested?
No, wasn't he the guy with the bad injury? I think he had a horrible leg injury. Am I thinking about the right guy? I'm pretty sure. Yeah. So, I mean, career-ending injury. That's why his name, you remember his name. At least you've heard of his name.
Hey, Eli, you should come over. We'll make nachos.
I'm playing tonight, Pete.
No, you should.
All right.
Set a pension for
So, here,
the
let's
playoffs.
shut up! All right, so we're going to implement these registers as separate 8-bit integers. Now, when we think about like the move command, and we're implementing the move command, okay, move is going to ultimately be a function, right? So we'll have a function that gets called, and it's going to call with a destination and a source. Those two things, right? Okay, so we've said that our destination can be what? So we're going to have we can just say public void move. This guy will be an int array destination. So initially we're just going to allow movement into registers because we haven't implemented memory. we'll think about memory, but right now we haven't implemented this. So we're going to call this destination register for right now. And that's going to be an int array. And then this guy is going to be a value. And that'll be an int value. All right. So now to actually implement this, let's think about some of the conditions. If they pass in AH and the number 17, for example, what do we need to do? So AH and 17. In order for this to work with our implementation, what will we need to do to that 17? Convert to binary. So right off the bat, we need to convert that guy to binary. All right. Then we need to put it in AH. When are we allowed to put it in AH?
Feel like it.
Okay. Well, actually, let's look at this. Let's see the behavior of an 8086. What happens if I try to put in a value that's larger than what 8 bits can hold? So give me a value that's just larger than what 8 bits can hold. Don't just give me 10 million and say, probably can't hold that. So give me, what's a number that's just a little bit too big for an 8-bit register to hold? This isn't something you really need to memorize. What'd you say? 256. So 2 to the 8th power, right? Is 256. Or what if it was signed? Negative what to positive what? All right, try it again and give the right answer this time.
Negative 128 to 127.
Negative 128 to positive 127. Was that bad?
A little bit.
Really?
Yeah. No.
What, did you want me to sugarcoat it? You got to do the reinforcement because he made the same error earlier.
Funny story about that.
About what? Negative reinforcement?
No, sugarcoating. Sugarcoating responses.
Oh, I gotcha. See, now he won't make that mistake again. Right? He doesn't want to cut it in half.
He's just not going to answer it again.
He's like shaking his head.
I feel people are like scared to answer in 325.
Why? Because they're afraid of me?
Yeah, because like
Really?
because Alex and I and Zach, Doctor, like the only ones that talk in that class, with a few exceptions.
That's why I try to call on the other people.
I know.
Is that the group that I was with?
Yeah.
Yeah, they're all really quiet.
I don't think so.
Are they wimpy? Are they dummies? Maybe they're dummies.
The couples I knew. The couple of them that I knew weren't.
What if I had the recording off? Would I have a different? Would we get a different response to that?
You
All right.
You're their teacher.
Yeah. You see their work.
I mean, some of that stuff makes me sick to even look at. Can't do that. All right, so negative 128 to positive 127. But if we're doing this as signed, so if I do 256, is that too big?
Yes.
Is that too big, Tim? Tell me why you're wrong.
257 would be. Oh.
So now he's just backpedaling when he actually wasn't wrong. He was guessing.
257 would be right.
257 would also be too big. Okay, so this is a little bit too big. So the question is what's going to happen? What's going to be our behavior when I execute this?
Panic.
So it's shut down, reboot.
It's going to start from the.
You're going to have a flag. You're going to have all zeros.
Okay, well notice I'm loading this into the low 8 bits of AX.
So will it?
So we have AH and AL.
Oh, you'll have one in the high.
No, because
Nope.
because you're
You'll have one in the high you'll have one on the high end, but the low end will be zeros.
Okay. So what are some possibilities? One possibility is we're going to have similar behavior to what we had before, right? Where we targeted an 8-bit register. And we targeted an 8-bit register, and it overflowed that 8-bit register, and we should then have a carry flag. And in this case, we would also have a 0 flag. Correct?
Yep.
That's one possibility. Another possibility would be that it bleeds over into the high 8 bits of AX. Which do you think that is? Which do you think will happen? Go ahead. Think the carry bit? Why?
Because you're dealing with, because then it'd be a 16-bit number rather than the 8-bit number that you are doing the math with.
Okay. So first of all, we've already seen that the various commands in 8086 require that we feed them the same size data, right? That way they're picking the correct register. Does a world exist where we choose to use AX or AH and AL for separate purposes because we don't have 16-bit values we're working with 8-bit values? Therefore, wouldn't it make sense for us to not damage whatever we've been working on in AH by having AL bleed into it? So we're probably going to get the carry flag situation here, right? So let's go ahead and run this. Oop.
You need a space after the comma. Oh, it says
No.
over 8.
Oh, error message. It won't let you load a value over 8-bit, so it doesn't work on the carry.
Is it because you're not doing math?
Huh?
Is it because you're not doing math?
Well, we haven't even started math yet. But possibly. Actually, that's a good question. Let's do... No, because this worked. If I did this, I did 65,536, which is too big. This worked. Oh, no, it didn't.
Oh. It's because you're first storing the value. Yeah, you had
So an immediate value, it checks. It won't allow us to store a value larger than it.
That makes sense.
So
It's as a result of the arithmetic. So when we did 65,535, that works. And then if we do add, or we can even do inc AX to add 1 to it, that then we'll have the carry.
yeah. So try that with AL. Do the setting it at
Well, then we're going to have the behavior we said. So 255 will work. Increment AL. All right, so there's our FF, so maximum size value we can fit in there. Then we'll do our increment, becomes 0. We look at our carry flag, which is, well, that's set. But the carry flag did not get set.
Because you're incrementing, not doing.
that might be a thing. Try add.
Let's find out. Yeah. So increment does not have an impact on carry flag, add does.
Is this black magic?
Interesting. All right, so, well, I mean, it's not. I mean, that's the way 8086 worked. So you learn about the little things. All this stuff, I'm sure, is in the manual.
Which you need to memorize.
Quiz, verbose quiz on the manual next
What
class.
does the introduction say?
No, just, hey, you have 4 hours. Recite the manual.
Congratulations on receiving your 8086 process. This manual will now go.
At that point, you're better off just writing words and hope they exist.
All right. So back here to our plan. So when we move into the destination register. So actually for us here, the destination register will likely just be a string, right? The name of our register, potentially. Because if we think about this as being the function that's responding to a command, we're going to be moving this value, moving this value into this register. So first thing we need to do is convert value to binary. Then determine the type of register of DR. Desk register. What? Doctor. Then
So wait, why would you want it to be an integer array for the destination?
well,
Give me-
we could have done the logic before this, but what makes the most sense is for us to go ahead and when I type in as the user move AX comma 5, I'm going to pass AX and 5 to this function and let this function figure out which of my arrays AX relates to. Okay, so
you want it to be object oriented. You get a class called registers, and then you would have an instantation called AX,
we probably will.
and then you could have AX.
That'd be the better way.
Yeah,
to do it.
no, we very likely will. Well, that wouldn't be object oriented. I mean, you wouldn't have AX dot move.
No, you
Yeah,
would,
because
it's
AX would be
it's a register
instantation of
object.
that register. Yeah, it'd be an object.
Yeah, okay, but that wouldn't be that would not be a true
Okay, then,
implementation of what we're dealing with here. It's
If
the
you were
CPU, the 8086 CPU is the guy that has the movability,
Yeah, right.
not the
You-
register
You
itself.
would have
Would
a
it
static
be-
class with the word this in front of the assembly, so that way you could theoretically have that helper function then.
So then, arguably, couldn't you create one global object that is a CPU object, and then have register objects inside of that?
Yeah.
Sure, that's fine. Yeah, and what I'm saying is he was
Yeah,
saying
no,
he
yeah,
was
I
arguing that
agree.
the
No,
that you
I-
have three
yeah.
registers: the AX register, the
each
BX
have their own
register, the CX register. These guys are all register objects, and each of those register objects would have their own move function that knew how to move stuff into that particular
Gotcha.
register, which is fine from an object-oriented implementation perspective. But it's
no,
not true
yeah.
to our CPU because that's not how the CPU works. The registers don't know how to move things into themselves. It's the CPU knows how to move things into the registers. The registers are like the appendages of the CPU.
So you would need it like you have to have if you wanted to do it object oriented based, you'd have to have a CPU object that the registers are a part of, calling the CPU objects.
Yeah,
function.
sure,
The
sure.
CPU doesn't need to hold it. Yeah, the CPU should not hold the registers.
Well, I'm not saying.
Well,
has
it
to,
would.
But it would because you'd have to. Be
If
able
I'm
to-
looking at an 8086 processor, the registers are in that CPU.
Yeah.
They can hold register objects. But, I mean,
Yeah.
so if you think of the CPU, it's a box. And
So
inside that
yeah,
box, we have some registers. We got an instruction set. That's the stuff that goes into a CPU. So that would be an object, and then inside there would be, some of our objects, and there would be register objects. And what's a register object? A register in our world is either 8-bit or 16-bit, right? And 16-bit registers, some 16-bit registers, this is where things get a little wonky here. Some 16-bit registers are actual 16-bit registers where the full 16 bits is used. Some, like our general purpose ones, are split into two 8-bit sections.
Could that not be defined when you make the register object though?
I think that the cleaner way of doing this would probably be, you can create a register class that's filled up with static methods or static fields where you say registers.ax or something like that, and it knows what it is, rather than trying to do some sort of crazy stuff to differentiate. Because remember, we're creating an emulator here, and we're focusing on the organization, less about what is the proper, perfect way to represent this thing in an object-oriented manner. I mean, whatever we do is not going to completely suck.
In your CPU class, you could have a static dictionary with types with the actual configuration, so that is built
Yeah,
on.
fair enough. Yeah,
That way you would have everything be static.
you can write it whatever way you want.
Just
I'm not concerned. They're all completely reasonable.
so
All right.
that is-
So
Hey,
So-
I beat you technically.
definitely we need to convert a value to binary. Then we need to determine the type of register that we're trying to load it into. Then well, here, let's just make it just a bulleted list. List the, I'm sorry, throw error if value is too big. Otherwise, load value into register. Make sense? All right, so just for the move command, we're giving it a value. We're giving it the name of a register. And then we're having to convert that value to binary. So let's think about that. If I have an integer value, how do I convert an integer value to binary? Okay, fair enough. Let's just go over here to Eclipse. So let's say I have something like string s is equal to 1101. Actually, sorry, let's do this. They're coming in as integers. So int a is equal to 5, and then we want to get the binary version of that. String ab is equal to integer dot parseInt. Oh, that's going to give me an int. I need to go the other direction. Yeah, is it string to binary string?
Integer to binary string.
Okay.
Like, you remember all those things that we had to write? These big ones?
Yeah,
That converted it? Yeah, it was built in.
Yeah, I mean, that's the way a lot of this stuff is, right? All right, so then, although converting it to binary isn't overly difficult, so I mean, you might as well write it yourself, but this is a nice shortcut for ourselves. So that's why we're not writing it ourselves. System.println, AB. All right, so this guy should hold what? What binary number should this hold?
5.
1 in the 4's place, 1 in the 1's place. Okay. Like that. Now, what if I did -4? I want to make sure it works for that. So let's look at our 2's complement stuff. -4 should be 100. Row.
No, it's just really that's fine.
I don't think that's correct.
What is it?
Is that for?
Well, it's an integer, so it's a string of.
Oh, right, but in order for these would have to all be zeros in order for it to be the same. This is 32 of them, I'm
right, so
sure.
Yeah, because you're calling it as an integer, so the integer holds 32 whatever. But even still,
Well, so let's flip the bits. I think you're right, actually. So if we flip the bits, these will all be zeros, 1, 1, and then it'll be 100. It would be. But that's, yeah, no, that would be right.
For 32-bit, yeah.
That would be right.
So
if this is in 2's complement form, first thing we do is we subtract.
You flip it.
And then subtract. So this will give us a bunch of zeros followed by 2 1s. Then we subtract 1 from that.
You add 1 because you flip. You subtract before you flip. Add after you flip.
Subtract.
Because before we subtracted 1 and then we flipped.
Yeah,
if you flip, then we add.
Oh, I get it. I get it.
Oh, you want to add the 2's complement of 1, right?
No,
No, 4.
it's not the 2's complement of 1.
You want to get
You're
the
just-
2's complement of 4.
So this is 2's complement. We want to take it back into its normal value. So the normal value of this guy, we go from 2's complement to 1's complement. So we flip all the bits, right? So that gives us a bunch of zeros followed by 2 1s. All right, and then we subtract 1 from that, which means we add the 2's complement version of 1,
Yeah.
which was 1 1 1, right? So that is this number. Go back to our scratch space, wherever that was. So this is 0, carry the 1, 1, carry the 1,
It should be 0, right?
no. 1 plus 1 is 0, carry the 1. 1 plus 1 plus 1 is 1, carry the 1. 1 plus 1 is 0, carry the 1. So this is 0, 1, 0. So that's converting the number back to, so that's still not,
So that's negative 4 right there. And we want to convert it back to.
here's negative 4. We'll just put a bunch of 1s. It doesn't matter if it's 32 or not.
And then 2 zeros.
Then 2 zeros. All right. So first thing we'll do is we flip the bits like that. Now we already know that this guy represents a negative number since we knew it was in 2's complement form and we saw 1 out front. So that's negative. So now we have this. Now we need to add 1 to that, but we need to do the 2's complement of 1. So that's the 2's, that's 1. 2's complement of 1 would be a bunch of 1s, followed by a 0, plus 1 is that. All right, so now 1 plus 1 is 0, carry the 1. 1 plus 1 plus 1 is 1, carry the 1. 1 plus 1 is 0, carry the 1, 0, carry the 1.
It's still 2.
Yeah, that's still a 2. So I don't think that's giving us the right answer. It says this is negative 4?
Yeah.
All right, so then what are we doing wrong?
Well, didn't you have it right before where if you're trying to take the 2's complement of 1 and add that to the 1's complement of that number, you're gonna get.
Oh, hold on. It's what he said before, which is right.
Yeah.
We are flipping and then subtracting when we actually need to flip and then add, or subtract and then flip.
Yeah.
One of those two.
Yeah.
All right. So we're just moving backwards the wrong way. All right. So this is our current number. We can subtract from here, or we can flip and add. So flipping and adding is going to look like that. And then we add 1 to that, which is going to give us 0, carry the 1, 0, carry the 1, 1, which is 4. Right. There we go. Okay, so then we're going to say we're satisfied with what this guy looks like. But we will need to convert it into a string. Well, it'll already be a string, but we'll need to truncate it to the right number of characters.
Well, what do you want? Do you want it to be a byte? Because can't you do a byte to binary string?
Well, yeah, we could do bytes or shorts. Let's see
Yeah.
if let's see if that actually works. So if we do, let's do this as a. Well, let's do it as a byte just to see it.
Wouldn't that be byte?
Doesn't exist. Byte doesn't have a 2 binary string. Yeah, that doesn't have it either.
Well, can you convert an int to a byte and then do
We don't have to. We'll just, we just work with it's all going to be padded values, right? So this doesn't really cause a problem. We just have to know that we're going to have 32 zeros and ones, and we only keep 8 or 16 of them. And then we'll still have to check to make sure the value isn't beyond what we're allowed to store. But when we're dealing with 8 and 16-bit registers, those are known things, right? 8 unsigned 255 is the largest value. 8 signed 127 is the largest value. Negative 128 is the smallest value. The other side is going to be the 32,768 is there. 767 is the largest. Negative 32,768 is the smallest, or 65,535 is the largest. So it's just 5 values we have to hard code in there, and says if it's bigger than this, we throw an error, scream, whatever. Okay. So coming back down in here. So this was integer.to binary string, and then you pass it something like 5, and that will give you the that'll happen to give you truncated because it's exact. You can assume it's a bunch of zeros before that. So you also need to be able to pad out. So we probably need to say something like this: convert value to binary and pad appropriately. Okay. Determine the type of the register. So in our world, is it an 8-bit or a 16-bit register? Throw an error if it won't fit. Otherwise, load the value into the register, which is where it becomes important for the padding thing. Okay? And since move doesn't actually deal with any flags, we don't need to think about flags at this point for implementing move. That make sense? All right, so let's go into our project here. So we'll start a new Android Studio project. And we'll do com. Looks good. And we'll call this 8086. I'll call it emu 8086.
It's just string format.
All right. And I'll go ahead and let it, I need to store this in a different place.
It's on the end of the thing.
What's this? Where's my Concordia folder?
integer dot to binary string, and you can pass it the byte.
And then does it pad appropriately?
I believe so.
You have to give it the string to pad it correctly. The string format.
So it's emu 8086 Android. All right, so I'll go ahead and create this. Minimum SDK. This will hit 97.4% of all devices. Cool. So leave it at that.
The top 3. The target nougat, whatever they're calling it.
I don't think we're going to be doing anything that's going to take advantage of any of the newest, latest, greatest widget stuff.
Yeah, but we can say everyone here can write it on the resume that they run an app for nougat or whatever.
Can't you do that anyway? I think isn't it just nougat? I guess how you say that word.
Nougat? Like the stuff inside, like.
Yeah, I mean, they name all their stuff after desserts and stuff, so I'm sure it's nougat. All right, so I always choose empty activity as my...
Spell it. N-U-G-G-T. No, it's now N-O-U-G-A-T.
Okay, and let's call this, we'll just call it main activity. It's good enough. What's up? Your leg fell asleep?
Yeah.
So you say that this gets better. Like, has their simulator gotten any better?
Yeah, a lot.
Okay, good. 'Cause if anything, that was the worst part.
It's gotten a lot better.
You lying?
No, I'm telling you, it's a.
Nougat.
All right. So here's our project here. The Java, so it's inside of app. The Java source is here called main activity. All right, so activity is something we see on the screen. Let's just assume that that's a true statement. All right, and I think this guy just does the hello world guy by default. So there's our actual activity, and our resource folder here is where our layouts are. So our first screen is this activity main XML. So it's loading the preview for that guy or whatever.
Did they release any iMacs or MacBook Pros yet?
No, he's like 2 years overdue. No, they haven't announced them yet.
Were they supposed to announce them like?
2 years ago.
So did they discontinue that product line or?
Well, didn't they last year? They did come out with like
A MacBook,
that MacBook.
but it only has one port on it.
Yeah, it's not a MacBook Pro though. That's a ultra portable thing.
Are they just trying to shove the iPad Pro down your throat or something? Just not release any new laptops and only say, here's your iPad Pro? I don't care what you do.
Change it from the 23 at the top.
Oh, change this guy to. I did it as a 15. Yeah, I told you this thing's like way better.
Slow as the best error message is in the world.
Looks a little bit.
Tip: try to refresh the layout. Here, let me just quit Android Studio.
Do you have a bunch? How many APKs or whatever do you have downloaded?
Like 2. Not very many. So I guess it's possible I chose a level that I don't have the.
You see some dude in Australia patented the hand dog.
The Who Dog?
Hand dog.
The hot dog hamburger.
With a special bun and everything.
Oh, very nice. Okay, yeah, here it goes.
How does Australia
All right,
compare
shut up!
to the-
So it seemed to work this time. All right, so I'll go ahead and run this, and it wants to create a virtual device. So I'm going to use this Nexus 5, blah, blah, blah.
Not the Nexus 7. Here we'll start in 5.
So it's loading my emulator. It should show our little hello world guy here.
Actually, there's a test with material design. It's so much cleaner than the old UI.
All right, so let that guy cook for a second. It doesn't take very long for it to load. There we go. Go ahead and launch that, and there's our Hello World app. All right. So now what we would want to do is we want to be able to enter in. Let's start off with a single text box that brings some information in, like move, name of register, comma, value, just to show that we can show what the registers look like. All right, so I'm going to come in here and minimize this. This guy gets bigger. I'm going to go ahead and delete the hello world there. I'm going to throw a, here's my widgets. I need a layout. So I'm going to do, all right, focus. We only got 5 minutes left, and you're going to be writing most of this on your own if I don't give you something to start with. Well, do you want something to start with, or I can stop whenever? I'm cool with that. All right, so I threw a vertical linear layout inside there. That way everything will just kind of stack on top of each other. And then I'm going to go ahead and get an edit text. So here's my text fields, and this guy's just going to be a plain text box. So I'll throw that guy in there. So here's my edit text. And then here's my, actually this is like actually way better than it was yesterday. Because yesterday this was still that whole like old version where you had like 4 million things. All right, so the hint is kind of like placeholder text, so we're going to call this, enter 8086 instruction. Something like that. We'll take the text out of there. So there's our 8086 instruction. Oh, here's the view all properties thing, because we want to set some gravity to have this thing centered real quick. Well, actually, I don't want to do that because we're a little bit low on time. So let me just double click on this. Let's change its ID to instruction ET for edit text. So that's the name of that text box. And then just as a to do this example, so you have a starting point, I'm going to go ahead and throw a text view out here. So this is like a label. Okay, we're going to call this guy output TV for text view. So that's the name of that variable. Okay, we'll put, we'll leave the value in there for right now, I guess. Well, whatever. Let's call this output. All right, so now we're going to go into our code. Main activity, and I'm going to give myself a, we actually need to give ourselves a button as well. So I'll put the button before our output, and the button will just say click me. All right, now here we'll say emulate. Okay, so there's the emulate button, and then we're going to have an on-click property for this guy, and this is going to call emulate button pressed. I'm going to steal that here. We'll go into our main activity, public emulate button pressed, view V, option enter, there you go. Oh, it's public void. Okay, and then what we want to do inside here is we want to go ahead and, well, here, we'll give ourselves global variables here for our couple of guys. So we're going to have a private edit text. And this guy is going to be named, what do we call it? Instruction ET. And then private text view. And this guy will be output TV. And then we'll go ahead and set those two variables. So at runtime, when this launches, we need to link these two variables up to the widgets that are actually on the screen. Okay, so we do that like this. So we'll say this dot instruction ET is equal to the edit text version of this dot find view by ID r dot ID dot instruction ET. Then this dot output TV is equal to the text view version of this dot find view by ID r dot ID dot output TV. All right, so then we've linked those two guys together, and then in our emulate button pressed function. So this is the guy that gets called when that button is pressed. We're going to go ahead and let's just set our output equal to whatever's in the text box. So we'll say this dot output dot TV set text to this dot instruction et dot get text. All right, go ahead and run this. All right, so here's my instructions. So if I do move AX, comma 17, and then I click emulate, it shows me that it read it in and it put it out there on that label. Make sense? All right, so for us, for our homework assignment, and I'll even take 2 more minutes here real quick and just throw some stuff out here. We might want, we're going to have 4 registers, AX, BX, CX, DX, right? So why don't I go ahead and do something like, do a couple of linear layouts out here. Where's my layouts? No, it's right here. So here we'll do a horizontal linear layout. And inside here we'll put a text view. And we'll also put another text view for its value. So this is going to be AX. This will be value of AX. Something like that. And this guy will have wrap content, so we can make that smaller.
Is that another linear layout for the output?
Who?
Did you add 2 linear layouts, or is that just 1?
I added 1 new one. So here's this new one I just did right here. And then I'm going to go ahead and copy that 3 more times. So that's BX, CX, DX. Yeah, they're all horizontal just to be next to each other. There's BX. CX. And DX. All right, so those will be our 4 registers that you can have the values for that. All right, so I'll push this up to GitHub so you can have this as a starting point. And I'll put up, how many of you have never used GitHub before? Okay, everybody's used GitHub. So I'll push it up to GitHub so you can pull this as a starting point. You can even check it out from Android Studio. So for your homework, there's going to be a paper topic. Actually, maybe I won't give you a paper this week. Let's just do this week. Okay, but make sure you have all of the, make sure you have the emulator installed if you don't already have it. So that'll be your side home. Instead of the paper, make sure you have a working emulator. But for this programming assignment, you should support a move instruction into one that allows you to move an immediate value into one of the 4 into one of our general purpose registers, either the 16-bit versions, which we have listed here, or the 8-bit halves of them. Okay. All right.
So
So
do you want us to do like the AL and AH under the AX?
that's fine. I don't care what you have your output look like. This just gives you a starting point for it. You can just, if you want to list all the other ones underneath as the lesser registers, that's fine.
So when you do, well, AL and AH, do those always get filled? Is like when it shows it, or no?
Yes.
Everything's zeros
Okay.
by default.
Yes. No, but like, but say you put a number to AX, does AH and AL get filled automatically?
Yes.
Okay.
But it starts with, it'll start right to left.
Yeah.
So if you put the number 3
Starts
into
with
AX, you're going to, AH will be a bunch of zeros.
Yeah. Okay.
And AL will just be a bunch of zeros followed by the 1,
Okay.
1, 1.
So what's the reasoning behind using the app Google versus the other one? Why an app to begin with?
Well, why not? Isn't that less boring than just writing a Java program or something?
I suppose. Unless we're doing it in